Inheritance is nothing but applying the properties of one class to the another. Class is nothing but a blueprint, okay, for creating objects. So how is it created? Whenever an object is formed, then this constructor will be automatically created by the system. Polymorphism is nothing but over here the classes or the methods will be behaving differently. Hello guys, welcome you all to the first session of second unit that's under BCA graduate program. Absolutely, this is under SCP syllabus, the new updated syllabus by MYSURU University. Over here, my name is Deepa Kutnikar. I'm working as an assistant professor under Department of Computer Science, Vidhyaashram, Temple of Excellence, Mysuru. Over here, with respect to Unit 2, it's all about OOPS with C#. All right. Up next, let's see exactly what's the agenda of today's session. Today's session is all about these topics, like we'll be starting with introduction to OOPS, and then we'll be having classes and objects. Like we'll be discussing what is the classes and how it works with respect to the C#. That's OOPS with C#. We'll be learning what are different constructors, what are the destructors, and as well as we'll be understanding what is inheritance and different types of inheritance like single level inheritance, multi-level inheritance, hierarchical inheritance. Also we'll be learning how to define a subclass, what is the visibility control. Then we'll also be learning exactly what is method overloading. Then we'll also be understanding what is operator overloading. So these are the topics that we cover over here in the session today. Let's move forward and understand what exactly is OOPS with C#. Introduction to OOPS with C#. Yes, absolutely. As we know, C# is a powerful tool and it is one of type safe as well as object-oriented programming language, which is nothing but OOP, which is developed by Microsoft. Yes, absolutely. We know this and we have already discussed this in our previous unit. Now, let's see what are the concepts that are very, very important when we consider OOP. All right. The OOP supports the following concepts. First one is encapsulation. Encapsulation is nothing but binding the data as well as the methods with that manipulate the data within a class. Encapsulation, as the name itself says, our data will be encapsulated or it is being provided with a safety and security with the encapsulation. Up next, the second concept which is supported by OOP is inheritance. Inheritance is nothing but applying the properties of one class to the another. So that's what is nothing but inheritance. The next concept under OOP is polymorphism. So polymorphism, we can say if a method or a class has to behave as some other class, then that kind of concept is nothing but polymorphism. So over here we can have a look it is the ability of a method to behave differently according to the context. Which context? According to object context. So this is one more concept. Up next is the abstraction. Under abstraction, whenever the abstraction is called, it will be providing only the data which is essential and it will be completely hiding the complete or the overall data. So that property is called as the abstraction. So we know the .NET framework, it has a rich set of libraries. It has a rich set of libraries as well as runtime support. Yes, exactly. This is all about the introduction to OOP with C#. Okay, let's move forward. Over here, the next concept is classes as well as the objects. So class is nothing but a blueprint, okay, for creating objects and also will be encapsulating data for the object, okay. So this is nothing but a simple class. Now let's see an example we are considering a class student and we are writing some statements like public string name, under which we'll be writing the names of the students, and we are creating a display block wherein we are writing a write line as name. So this is a simple block which depicts a class. Up next, let's see what is an object. So object can be called as an instance of a class, alright. So over here, it can represent the real world entities. The object is considered to represent the real world entities. Okay, so now it helps implementing modular, reusable as well as maintaining the code. It supports in maintaining the code, modular, reusable as well as for maintaining the code. So this is nothing but a simple object. And now let's see an example over here. Like we are defining a student with S1. Yes, we are assigning, and we are assigning a new student. Okay, so now we can see here the new student is being named. Okay, and yes, we are displaying that student name. This is all about the classes and the object. Moving forward, let's exactly understand like what is a constructor in C#. So constructor is a special method and it will be having the same name as that of the class. Okay, so yes, it is having the same name as that of the class. So this is all about a constructor. Following, let's see how this constructor is created. Okay, so it is automatically called when an object is created. So how is it created? Whenever an object is formed, then this constructor will be automatically created by the system. Let's understand what are the different types of constructors that we have or we utilize. So the first one is a default constructor which works without any parameters. And the second type is a parameterized constructor. So over here, as the name itself implies, it will be defined by using parameters or a set of parameters. Next one is a copy constructor. So this constructor will be holding a copy of an existing object. So it is called as a copy constructor. Up next is a static constructor. It initializes the static members of the class. So these are the various types of constructors that we utilize with respect to C#. And over here, let's see an example statement. Over here, we have defined public student with a string. Okay. Yes, and now I'm assigning that into name. So this is the simple statement or an example for constructor. Up next, now we understood what is a constructor. Moving forward, let's understand what is a destructor. Destructors are used to deallocate the resources of the system. Okay, now it is defined in this format. So you can have a look over here. It is defined as a class name of followed by syntax. It is implicitly invoked by the garbage collector whenever we can say this is implicitly invoked by the garbage collector when you won't use the file for a long time. Okay, so that's where the destructor is utilized. Up next, let's see how the C# doesn't support destructor overloading. Okay, so C# own or not at all supports the destructor overloading. So over here we can see example statements like we are considering or defining a student block and we are writing a write line, that's a console dot write line followed by the destructor call. So this is a small block of code which we can use as a form of syntax for our destructor. Moving forward, let's understand like what is inheritance in C#. Inheritance is nothing but we will be inheriting something. Okay, so exactly inheritance is nothing but it is a class where the newly formed class will be created. And how was it created? It is been created by taking a support or help of base classes or the previous classes. So that's all about inheritance. So let's have a look over here. It is a class. All right. So yes, absolutely, it is a class. And over here, it inherits members from other classes, which we call it as a base class. All right. Up next, let's see what does it do. So inheritance will help C# to reuse the code. It will be very useful for readability as well as organization of the code. So this is about inheritance. Up next, let's see a simple syntax. So over here we are defining inheritance. Yes, as you can observe, we have written class derived is to base. So what are the sentence, or if any sentence is required, we will be writing under this curly braces. Alright, so this is all about inheritance, where we will be inheriting few of the behaviors of the previous classes, or we can call it as a base classes. Next, let's understand like what are the different types of inheritance that we have. Different types of inheritance like single inheritance, multi-level inheritance, hierarchical, and so on. So let's understand one by one like how it works and what is the syntax for that. Moving forward, over here we have a single level inheritance. So as the name itself says, over here we will be only utilizing or working with a single class. Yes, we can see it is a fundamental concept. Yes, absolutely it is. And the object-oriented programming, where a class or subclass inherits properties, methods, or behaviors from only one other class. Please note this, only one other class. Or we can call this other class as a either subclass or superclass, and even we can call it as a parent class. This is a very simplest form of inheritance, and we can call this as a parent-child inheritance. So over here we have a small syntax or an example for this. So we are defining a class of animal, alright, and over here we are considering the eating habit. So alright, we are defining or assigning public void eat. So what are we assigning? We are assigning eating under the console write line. So now what is the class I am inheriting? It's a single class and it's a dog. So we are representing under animal followed by braces. Okay. Now what does it mean? Dog inherits eat method from animal. Yes, exactly. It promotes reusability of code. So this is a very simplest form of inheritance, but is nothing but single level inheritance. Moving forward, let's understand like what is multi-level inheritance is. Yeah, over here multi-level inheritance, as the name itself specifies, we can consider different classes in order to derive our derived class. Yes, absolutely. Over here we can see each derived class builds upon its base class. All must be having the behavior of the base class. So it is called as multi-level inheritance, and over here let's see what it promotes. It promotes layered inheritance. Yes, absolutely. As we are working with multiple level inheritance, we can call it as a layered inheritance also. So let's see an example. Over here again we are considering class animal of, and we are defining a class under dog. Also we are subdefining the class into subclass as a puppy. Okay, so this is a class puppy. So over here we are working on two types of classes, which is dependent or which has the behavior of the main class, or we can call it as a base class. So over here the base class will be forming as an animal, and the derived class is nothing but a dog as well as a puppy. Alright. Now let's understand like what is hierarchical inheritance. Over here we can observe the multiple classes will share the common base class. Alright. So now what does it promote? It reduces redundancy of a program or a block of code. So now let's see a example over here. Yes, absolutely. Again we are considering animal has my base class. Alright. Up next I am defining a dog. Okay, that's my first derived class. All right, it's done. And up next I'm also considering a class cat. All right, so this is a second derived subclass. So in this way we can go with the hierarchical classes with considering different subclasses with respect to the base class. Next, let's move forward and understand like what is containment inheritance. Promotes the composition over inheritance, and here we have an example like we are considering a car. So class engine, all right, I am defining a class All right. So now I'm defining a class car of engine, new engine. So as we know, car absolutely it has an engine. Yes. Then what is my derived class? It is nothing but a engine one, or we can call it as a new engine. So this is about the containment inheritance, and we can also say it has a relationships. So it will be having a relationship with the base class as well as the derived classes too. Till now we did understood like how the classes are defined and derived. Now let's understand like how the subclasses are defined and what is the visibility control. Yes, let's move forward. Subclasses are used to define the base classes, alright? So yes, correct, we need that base class whenever we consider inheritance. So as we have multiple inheritance, it is better if we call a block of code as a subclass, alright? Up next, let's see how the visibility is followed with respect to C#. Visibility control, we can also call them as access modifiers. So under this access modifiers, we have different modifications or different updates which the program can call according to that requirement. So the first one is a public, as the name itself says, we can access the class or subclass or the visibility from anywhere throughout your block of code. Alright, up next is a private, as the name itself says, it is completely accessible only within the class. It is very private to that part of code only. Next one is a protected. This is accessible only by the derived class. Derived class is nothing but a new subclass which is formed by following the base class. Correct? So that's under protected. Up next is internal. Internal, it promotes accessibility only within the same assembly. Next one is the protected internal. Over here, we can understand this protected internal. It provides the combined support of both protected as well as internal modifiers. So these are the various access modifiers that we go with visibility control. Let's move forward and understand like what is polymorphism with respect to C#. Polymorphism is nothing but over here the classes or the methods will be behaving differently according to the base classes. Okay, so over here we have two different types of polymorphism. The first one is a compile time, or we can also call it as a static polymorphism. The next one is runtime, or we can also call it as a dynamic polymorphism. Under this compile time, we have two more types, that is method overloading and operator overloading. Followed by under runtime, we will be defining the method overriding. So please note the difference. Under class time, we'll be defining or understanding like what is method overloading as well as the operator overloading. Followed by under runtime or the dynamic polymorphism, we'll be understanding like what is method overriding. So this is all about polymorphism, which exactly says many forms. Alright, so let's move forward. Let's see what is method overloading. So we can say it is a same method name with different parameter list, alright, wherein it improves by using this method overloading. We can improve the readability as well as the flexibility of a method invocation. Let's see a small example over here with respect to method overloading. We are defining the class print. We are also defining a block of code where we are or where we want to show the overload. So it's void show of int x, followed by we are specifying the string like exactly where this overload has to be verified. Now let's head up and understand this in a better way. Like this method overloading enables runtime polymorphism. Yes, correct, we know this, right? Also, the base class method must be marked virtually. Please note here, it should be marked virtually. Now, the derived class with respect to the method must use the override. Alright. Now, let's see an example. That's like we are defining the base class followed by a virtual void display. Why is it virtual? Because yes, I'm defining or I'm going with method overloading. Under that, we'll be writing statements like we are defining a derived base, which will be having a basic behavior of your base class, which will be having a similar behavior of your base class. So this is with respect to override. Yes, absolutely. This is a form of code for method overloading. Okay, this is just a small example. You can just write different set of statements under this, but please mention the virtual void display. Let's move forward and understand exactly like what is operator overloading. So this is a second type under compiler type overloading. So let's see what is operator overloading. As we know, absolutely, this is all about the different set of operators that we utilize to write our code. See here, it will allow the operators to be redefined or given special meaning whenever it is used along with user-defined data types. Alright, so we can say like this enables more intuitive as well as natural syntax for manipulating objects. Alright, so now let's see what does it redefines. Yes, absolutely, it allows redefining how operators works with the user-defined types, defining the static complex operator by using a complex numbers. All right, so now we are returning the complex value with a real and imaginary part differently. That's where our program or the line of code ends, and over here we can see its overloadability, and we can also use the unary as well as the binary operators. So these are the various operators as we know we will be utilizing through our operator overloading. This was all about today's session, and this is with respect to next session that's under unit 2 itself. So in next session we'll be exactly understanding like what is data abstraction with C#. We'll be also understanding like what are the different abstract classes as well as the methods, followed by sealed classes, methods, and then the interfaces with C#. Also we'll be learning like how we can extend and implement the interfaces, then followed by the difference or the comparison between the class as well as the interface. That's for this session. Thank you.